All right, well, in this chapter section 4-7, we're going to be working with looking at the transformations of quadratic graphs. And in it, we're going to be writing functions in vertex form. And then we're going to write equations given a graph. And then we're going to graph equations in vertex form. So we're going to be dealing with something called vertex form. Now, we see here that vertex form equals y equals a times h minus h squared plus k. And in this, the value of h and the value of k represents the vertex of the parabola. And when x equals h, that is going to be the axis of symmetry. And then a, the coefficient a, determines the shape of the parabola and the direction in which it opens. And so we're asked here to write the function in vertex form. And we're going to be using the tool of completing the square. And also, I guess, in a way, we're going to be looking at grouping in order to do this. And so we're going to take this portion of the equation right here, in this case, x squared plus 4x. And we're going to break it down and complete the square. So let's get started on this. So we've got now y equals. Now remember, to complete the square, I'm going to take this coefficient, this linear coefficient, and I'm going to divide it by 2 and then square that. So 4 divided by 2, and that's positive 4, equals 2. And then 2 squared equals 4. So now I'm going to have x squared plus 4x plus 4. And that's a perfect square of x plus 2. And since I'm adding 4 to this equation, over here for this c value or k value where I got 6, since I'm adding 4 right here, I'm going to have to subtract 4 here. Now, when I do that, if you look at it in essence, I've not changed the value of the equation. I added 4 and I subtracted 4, and so the expression, the value of the expression is going to remain the same. And so this is now going to leave me here to get this in vertex form. I'm going to have y equals, well, this is a perfect square. This is x plus 2 squared. We know that from completing the square. And then positive 6 less 4 is going to give me plus 2. Okay. Y equals x squared plus 4x plus 6, written in vertex form, equals, will then become y equals x plus 2 squared plus 2. Now, this 2 here, h, and this 2 here, which is now k, that's going to be the vertex of the parabola. So when x is positive 2 and y is positive 2, that's the vertex of the parabola. When x equals h, in other words, when x was equal to 2, that's going to be the axis of symmetry. And a determines the shape of the parabola. Well, a is positive 1 in this case. And so it's going to be, end behavior is going to be upwards. And it's just going to be kind of a standard parabola. So this graph here, let's say this is 2. This is 2. So I've got a vertex right here. The axis of symmetry is going to be the same on this around this 2. X equals 2 right there. And since I've got a coefficient of 1, the graph of this is going to look something like that. Excusing my sloppy drawing. Okay? Lots of fun, isn't it? All right, so now we're being asked to write this function in vertex form. Well, we got y equals 2x squared minus 12x plus 17. Now you may notice right away that we have a coefficient, a quadratic coefficient here greater than 1. And that's going to present a different step for us. So we're going to look first then at taking this portion of this expression, this equation, and completing the square of it. So I've got y equals. Now I'm going to factor out, since I have a coefficient greater than 1, you may remember I've got to get this x squared, or the variable squared, to just a coefficient of 1. So I'm going to have 2 now times x squared minus 6x plus 17. Now, since I divided here, I'm going to end up multiplying here, but I'm going to put as a placeholder here negative 2. All right. Now, let's look at completing the square. I've got negative 6, the linear coefficient b, divided by 2. That gives me negative 3. And negative 3 squared equals 9. All right. Let's go to the next step here. So I got y equals 2 times x squared minus 6x plus 9 plus 17. Need to put that as a plus. No, I'm going to leave that as a negative. Yeah, I'm going to make that a plus. Plus 2 times negative 9. Because I added 9 here, I'm going to subtract 9 here. I divided by 2 here, I'm going to multiply by 2 here. There's my 9 and negative 9. Okay, so let's continue to solve. So now I've got y equals 2. Well, I had this as a perfect square. This portion right here is a perfect square of x minus 3. Got my minus 3 from right there, squared, plus 17 plus, let's see, positive 2 times negative 9 is minus 18. And let's finish this off. Y equals 2 x minus 3 squared minus 1. All right, so we've written this now in vertex form. What does this tell us? Well, my vertex is going to be at negative 3, negative 1, x negative 3, y negative 1. Let's see, 1, 2, 3, negative 1. So I got a vertex right here. And negative 3 is going to be my axis of symmetry. I've got a positive coefficient of 2. And it's going to tell me how I'm going to open up that parabola. And so my graph is probably going to look something like this. Okay, there we go. Writing functions in vertex form. Seems kind of weird, doesn't it?